So, all together in the name of the Father, the Son, and the Holy Spirit. Amen. Dear Lord, thank you for the blessings that you gave us. Please guide us in our lessons for today, and hopefully we may get all of the lesson and understand them. In Jesus Christ's name, amen.
Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Pleasant afternoon, everyone. Praised be Jesus and Mary.
Now and forever.
Amen. Okay, so welcome back. No, this is another week na ato ang i-allot to discuss or to continue our discussion in preparation for the upcoming midterm exams. So just a little reminder lang, ang to ang midterm exam karon ng Thursday o Friday. I hope by those days mentioned, andam na tanan mo atubang sa ilahang tagsa-tagsa ng mga exams. For our course, no, sa ato ang klase, we will be spending our week na lang ko i-cover for the last time part sa ato ang data pre-processing, and then I don't know how we are to do it, but I know you have your schedule tomorrow sa inyong 3 to 6, no, naman may klase kay Sir Balaman, if I'm not mistaken. So I cannot invite you to join my other class para unta. Both classes will have 2 meetings at least for the week. Okay? Pero sige lang, nevertheless, kung unsa man ang makover na mo sa amo ang second meeting sa PICA section, I'll do my best nga ma-provide po to sa inyo, ha. Okay? Para tanan ta matagaan og equal chance nga makaandam before actually having the exam on Thursday and on Friday. Now for this afternoon, before ko mo proceed sa ako ang i-discuss o sa ako ang i-demonstrate, I'll be asking you to first watch a video, no? So kani nga video nani siya kinalaman sa ato ang i-discuss karong hapon. Nani siya kinalaman sa ako ang i-demonstrate, no? So para mas dali sa to asabton ang mga bagay-bagay karong hapon, it would be best to watch the video. So ang link ihatag nako sa inyo, ha. I'll give you time to finish the video. Di man nga na pud ka taas kayo, and then I assure you listening to the video won't necessarily get you bored, no? Kay dili man siya nga na good ka lisod i-comprehend even if the topic itself is a little technical. Okay? So hopefully you get to finish the video kay again dako siyang tabang aron mas mapadali sa tuwa masabtan kung unsa man galing ang akong i-explain later on and unsa akong i-demonstrate later on. So kani nga topics na atong i-cover karong hapon, nani siya kinalaman gihapon dito sa ato ang gisugdan gani. If you could still remember several sessions ago, gi-identify nato unsa tong mga specific activities that we can actually do as part of data pre-processing, no? Gi-emphasize man to nato good last time nga before ta mo abot sa actual nga analysis, isa sa mga importanteng steps nato ang agian is to do data pre-processing aron masiguro nato nga by the time mo perform ta sa actual nato nga analysis, ang ato ang data na gamiton in creating the model and training the model and eventually in doing the actual task of classification, clustering, regression, association rule mining, mamahimong dali na lang para sa ato ang mga models ang pagtuon sa data, considering nga na pre-process na nato, natanggal na nato itong mga issues, na-address na nato itong mga issues sa itong data, and then we were able to do other different steps depende pod sa kung unsay gikinahanglan sa tuang dataset. So kaning duha ka topics natong i-cover karong hapon na ani siya kinalaman didto sa katuganing wala nato na cover last time. We have identified 5 common steps in data pre-processing. So far na-cover nato last time sa atong demonstration si quality data assessment, si aggregation, og si sampling. Okay, unfortunately, we weren't able to cover dimensionality reduction and feature encoding. So kaning duha mao ni ato ang focus karong hapon. So without further ado, mao na ang link sa video. Palihog na lang kog check diha sa ato ang chat box. So my time now is 3:15. The video is approximately 21 minutes. By 3:45 mag-resume ta sa ato ang discussion proper, no? So please make the most of your time. Samtang wala pa 3:45. Tanawa ang video and then humana. Okay, I will meet you in a little while.
Measure one gene, we can plot the data on a number line. Mice 1, 2, and 3 have relatively high values, and mice 4, 5, and 6 have relatively low values. Even though it's a simple graph, it shows us that mice 1, 2, and 3 are more similar to each other than they are to mice 4, 5, and 6. If we measured 2 genes, then we can plot the data on a two-dimensional XY graph. Gene 1 is the x-axis and spans one of the 2 dimensions in this graph. Gene 2 is the y-axis and spans the other dimension. We can see that mice 1, 2, and 3 cluster on the right side, and mice 4, 5, and 6 cluster on the lower left-hand side. If we measured 3 genes, we would add another axis to the graph and make it look 3D, i.e., three-dimensional. The smaller dots have larger values for gene 3 and are further away. The larger dots have smaller values for gene 3 and are closer. If we measured 4 genes, however, we can no longer plot the data. 4 genes require 4 dimensions. Wah, wah. So we're going to talk about how PCA can take 4 or more gene measurements, and thus 4 or more dimensions of data, and make a two-dimensional PCA plot. This plot will show us that similar mice cluster together. We'll also talk about how PCA can tell us which gene, or variable, is the most valuable for clustering the data. For example, PCA might tell us that gene 3 is responsible for separating samples along the x-axis. Lastly, we'll talk about how PCA can tell us how accurate the 2D graph is. To understand what PCA does and how it works, let's go back to the dataset that only had 2 genes. We'll start by plotting the data. Then we'll calculate the average measurement for gene 1 and the average measurement for gene 2. With the average values, we can calculate the center of the data. From this point on, we'll focus on what happens in the graph. We no longer need the original data. Now we'll shift the data so that the center is on top of the origin in the graph. Note, shifting the data did not change how the data points are positioned relative to each other. This point is still the highest one, and this is still the rightmost point, etc. Now that the data are centered on the origin, we can try to fit a line to it. To do this, we start by drawing a random line that goes through the origin. Then we rotate the line until it fits the data as well as it can, given that it has to go through the origin. Ultimately, this line fits best. But I'm getting ahead of myself. First, we need to talk about how PCA decides if a fit is good or not. So let's go back to the original random line that goes through the origin. To quantify how good this line fits the data, PCA projects the data onto it. And then it can either measure the distances from the data to the line and try to find the line that minimizes those distances, or it can try to find the line that maximizes the distances from the projected points to the origin. If those options don't seem equivalent to you, we can build intuition by looking at how these distances shrink when the line fits better, while these distances get larger when the line fits better. Now, to understand what is going on in a mathematical way, let's just consider one data point. This point is fixed, and so is its distance from the origin. In other words, the distance from the point to the origin doesn't change when the red dotted line rotates. When we project the point onto the line, we get a right angle between the black dotted line and the red dotted line. That means that if we label the sides like this, A, B, and C, then we can use the Pythagorean theorem to show how B and C are inversely related. Since A, and thus A squared, doesn't change, if B gets bigger, then C must get smaller. Likewise, if C gets bigger, then B must get smaller. Thus, PCA can either minimize the distance to the line or maximize the distance from the projected point to the origin. The reason I'm making such a fuss about this is that, intuitively, it makes sense to minimize B and the distance from the point to the line. But it's actually easier to calculate C, the distance from the projected point to the origin. So PCA finds the best fitting line by maximizing the sum of the squared distances from the projected points to the origin. So, for this line, PCA projects the data onto it and then measures the distance from this point to the origin. Let's call it D sub 1. Note, I'm going to keep track of the distances we measure up here. And then PCA measures the distance from this point to the origin. We'll call that D2. Then it measures D3, D4, D5, and D6. Here are all 6 distances that we measured. The next thing we do is square all of them. The distances are squared so that negative values don't cancel out positive values. Then we sum up all these squared distances. And that equals the sum of the squared distances. For short, we'll call this SS distances, or sum of squared distances. Now we rotate the line, project the data onto the line, and then sum up the squared distances from the projected points to the origin. And we repeat until we end up with the line with the largest sum of squared distances between the projected points and the origin. Ultimately, we end up with this line. It has the largest sum of squared distances. This line is called Principal Component 1, or PC1 for short. PC1 has a slope of 0.25. In other words, for every 4 units that we go out along the gene 1 axis, we go up 1 unit along the gene 2 axis. That means that the data are mostly spread out along the gene 1 axis, and only a little bit spread out along the gene 2 axis. One way to think about PC1 is in terms of a cocktail recipe. To make PC1, mix 4 parts gene 1 with 1 part gene 2. Pour over ice and serve. The ratio of gene 1 to gene 2 tells you that gene 1 is more important when it comes to describing how the data are spread out. Oh no, terminology alert! Mathematicians call this cocktail recipe a linear combination of genes 1 and 2. I mention this because when someone says PC1 is a linear combination of variables, this is what they're talking about. It's no big deal. The recipe for PC1, going over 4 and up 1, gets us to this point. We can solve for the length of the red line using the Pythagorean theorem. The old a squared equals b squared plus c squared. Plugging in the numbers gives us a equals 4.12. So the length of the red line is 4.12. When you do PCA with SVD, the recipe for PC1 is scaled so that this length equals 1. All we have to do to scale the triangle so that the red line is 1 unit long is to divide each side by 4.12. For those of you keeping score, here's the math worked out that shows that all we need to do is divide all 3 sides by 4.12. Here are the scaled values. The new values change our recipe, but the ratio is the same. We still use 4 times as much gene 1 as gene 2. So now we are back to looking at the data, the best fitting line, and the unit vector that we just calculated. Oh no! Another terminology alert! This 1 unit long vector, consisting of 0.97 parts gene 1 and 0.242 parts gene 2, is called the singular vector, or the eigenvector for PC1. And the proportions of each gene are called loading scores. Also, while I'm at it, PCA calls the sums of squares of the distances for the best fit line the eigenvalue for PC1. And the square root of the eigenvalue for PC1 is called the singular value for PC1. Bam! That's a lot of terminology. Now that we've got PC1 all figured out, let's work on PC2. Because this is only a 2-dimensional graph, PC2 is simply the line through the origin that is perpendicular to PC1, without any further optimization that has to be done. And this means that the recipe for PC2 is -1 parts gene 1 to 4 parts gene 2. If we scale everything so that we get a unit vector, the recipe is negative 0.242 parts gene 1 and 0.97 parts gene 2. This is the singular vector for PC2 or the eigenvector for PC2. These are the loading scores for PC2. They tell us that in terms of how the values are projected onto PC2, gene 2 is 4 times as important as gene 1. Lastly, the eigenvalue for PC2 is the sum of squares of the distances between the projected points and the origin. Hooray! We've worked out PC1 and PC2. To draw the final PCA plot, we simply rotate everything so that PC1 is horizontal. Then we use the projected points to find where the samples go in the PCA plot. For example, these projected points correspond to sample 6. So sample 6 goes here, sample 2 goes here, and sample 1 goes here, etc. Double bam! That's how PCA is done using singular value decomposition. Okay, one last thing before we dive into a slightly more complicated example. Remember the eigenvalues? We got those by projecting the data onto the principal components, measuring the distances to the origin, then squaring and adding them together. We can convert them into variation around the origin by dividing by the sample size minus 1. For the sake of this example, imagine that the variation for PC1 equals 15 and the variation for PC2 equals 3. That means that the total variation around both PCs is 15 plus 3 equals 18. And that means PC1 accounts for 15 divided by 18 equals 0.83 or 83% of the total variation around the PCs. PC2 accounts for 3 divided by 18 equals 17% of the total variation around the PCs. Oh no, another terminology alert. A S3E plot is a graphical representation of the percentages of variation that each PC accounts for. We'll talk more about S3E plots later. Bam! Okay, now let's quickly go through a slightly more complicated example. PCA with 3 variables, in this case that means 3 genes, is pretty much the same as 2 variables. You center the data. You then find the best fitting line that goes through the origin. Just like before, the best fitting line is PC1. But the recipe for PC1 now has 3 ingredients. In this case, gene 3 is the most important ingredient for PC1. You then find PC2, the next best fitting line given that it goes through the origin and is perpendicular to PC1. Here's the recipe for PC2. In this case, gene 1 is the most important ingredient for PC2. Lastly, we find PC3, the best fitting line that goes through the origin and is perpendicular to PC1 and PC2. If we had more genes, we just keep on finding more and more principal components by adding perpendicular lines and rotating them. In theory, there is 1 per gene or variable, but in practice, the number of PCs is either the number of variables or the number of samples, whichever is smaller. If this is confusing, don't sweat it. It's not super important, and I'm going to make a separate video on this topic in the next week. Once you have all the principal components figured out, you can use the eigenvalues, i.e., the sums of squares of the distances, to determine the proportion of variation that each PC accounts for. In this case, PC1 accounts for 79% of the variation. PC2 accounts for 15% of the variation, and PC3 accounts for 6% of the variation. Here's the S3E plot. PC1 and PC2 account for the vast majority of the variation. That means that a 2D graph using just PC1 and PC2 would be a good approximation of this 3D graph, since it would account for 94% of the variation in the data. To convert the 3D graph into a two-dimensional PCA graph, we just strip away everything but the data and PC1 and PC2. Then project the samples onto PC1 and PC2. Then we rotate so that PC1 is horizontal and PC2 is vertical. This just makes it easier to look at. Since these projected points correspond to sample 4, this is where sample 4 goes in our new PCA plot, etc., etc., etc. Double bam! To review, we started with an awkward 3D graph that was kind of hard to read. Then we calculated the principal components. Then, with the eigenvalues for PC1 and PC2, we determined that a 2D graph would still be very informative. Lastly, we used PC1 and PC2 to draw a two-dimensional graph with the data. If we measured 4 genes per mouse, we would not be able to draw a 4-dimensional graph of the data. Wah wah. But that doesn't stop us from doing the PCA math, which doesn't care if we can draw a picture of it or not, and looking at the S3E plot. In this case, PC1 and PC2 account for 90% of the variation, so we can just use those to draw a two-dimensional PCA graph. So we project the samples onto the first two PCs. These two projected points correspond to sample 2. So sample 2 goes here. Bam! Note, if the S3E plot looked like this, where PC3 and PC4 account for a substantial amount of variation, then just using the first two PCs would not create a very accurate representation of the data. Wah wah. However, even a noisy PCA plot like this can be used to identify clusters of data. These samples are still more similar to each other than they are to the other samples. Little bam. Hooray! We've made it to the end of another exciting stat quest. If you like this stat
Okay, done watching? Okay na ba tanan? Okay, how about the rest? Okay na pod? Okay, sige. So, katong video na inyong gitan-aw that basically sums up the concept of PCA, no? So, principal component analysis, which is one technique in doing the fourth step that we have identified before, kato si dimensionality reduction, no? So, if we are to really dig into the technicalities behind, no, the house, makita nato dito sa video na a portion of it tries to tackle the mathematics behind, no? Kung makita man ninyo na i-explain dito sa video nga you will really have to determine some values so that you get to arrived with the ideal result sa imuhang pag-implement sa PCA. Like for example, you will have to start identifying your number of principal components, and then for each principal component that you have, basically, di ba, kinahanglan nimo i-project ang imuhang data towards the line that represents your principal component. And then from there, you will have to do several computations. Okay? If we have to be mathematically adept about PCA, kinahanglan na to agian tanan. We have to manually go through all of those process. Kaya lang, since we are not necessarily required to perform PCA or to implement PCA manually, katutan ng mathematics behind those that have been explained in the video, dili na gyud dato to siya kayo kinahanglan hunahunahon or problemahon, no? Ay mo kabala kapag abot sa exam, you will not be asked to manually do those things. Okay? I just had to show you that para makasabot mo, no? Kay ang ato na lamang buhaton pag abot nato sa ato ang program na i-create, no? Sa ato ang notebook na buhaton, we'll just simply call built-in methods to perform these things, no? Ang pag-implement nato later on sa PCA won't necessarily require us to do the mathematics manually. So dali ra jud siya kaayo. You just simply have to call existing packages, existing libraries, and then within that packages or within that library, manawag tag method. And then we are done. We can proceed with the next steps that we want to do with our data. Kaya lang kung dili magud nato sabtuntong concept behind, wala ra gihapoy yung purpose. Dili na to ma-appreciate ngano ta nagatawag ani ngani na mga built-in methods, giunsa to niya pag generate sa saktong result, why do we arrive at a certain value or certain values. Kana tanan ng mga pangutana dili nato na matubag not unless natay sound understanding of the concept behind. No, so mo to ang gist nga nung kinahanglan nato tan-awon tong video. Now, with that, I know ang uban sa inyo would need more time to really grasp what the video is talking. Pero mind you, kato na video na inyong gitan-aw is one of those who are able to explain the concept in the simplest way possible, no? Kanang dili gani siya technically drowning. So sa mga dili gyud kaayo ing anak ka technical, dili ing anak kalisod sabton sa ilahatong video. Okay, so without further delay, proceed ta karon sa pag implement, no, sa concept ni dimensionality reduction through PCA. So I'll be showing you some implementation. So sa akong demonstration, it actually contains two, no? Pa-confirm lang ko if makita ninyo sa inyong end ang ako ang gi-share.
Makita, sir.
Okay, thank you for the confirmation. So sa akong giingon this actually contains two sets of demonstration, though ang pinaka muraog tagaan natog saktong panahon is our demonstration 1, because demonstration 2 is basically just a repeat of this one, though it uses a different data set and na-assay additional cells that aren't necessarily limited to just data pre-processing. Explain na po na ko unya, unsa to sila ng mga cells, unsa tong additional cells akong ginaingon, o unsa ginabuhat adto, no? So, let us just begin. Okay, napislit na ko ang run. So, it will try to run everything. Okay, so I guess nahuman niya. Now, ito hinahinayon. So, just like the usual, no, magsugod yun ta sa pag-identify unsa na mga existing libraries ang atong kinahanglan. Okay, so we will be using NumPy and Pandas. No, so I hope ma-recall ninyo unsay purpose nila. But in the second cell, makita ninyo natay laing library na gitawag. So I don't know if you are familiar with scikit-learn. No, it's another library in Python which is dedicated for machine learning and some data science activities, no? So it is the library that is considered to have a rich collection of built-in methods that represents various tasks and activities that can be done as part of machine learning and as part of data science. Okay, so makita ninyo din na ay mga algorithms that we usually make use in performing different machine learning tasks na dili na necessarily i-code pa nimo from scratch. With scikit-learn, you just simply call built-in methods, and then katong built-in methods, yan na ang mo perform adtong task for you. So without necessarily requiring you to code from scratch. No? So mo na yung naka-nindot. And for most of the parts of our demonstration, makita na to ni si sklearn, no? Another library that we'll have to take into consideration. So kani karon, kani nga line, this basically means that we are calling the sklearn library, and then part of that library is a package called datasets. So kabalo naman taon sa ipasabot nato no kung maka-encounter tag term na datasets. Kani nga package ni sklearn or ni scikit-learn is the one that we call whenever we want to access built-in datasets within the library. Diba? Kaya kung kahinumduman ninyo, ang usual na to ginabuhat, especially with the previous demonstration that we have, we visit different online repositories. Like if you could recall Kaggle and UCI, no? Dito na to kuha ng dataset, and then if there's a need, we have to download the dataset, and then ayha na to siya i-import, no? Sa ato ang notebook. If you could remember the example we had when we made use of read_CSV, read_table, kato sila itong mga pamaagi aron makatawag taog external files containing our dataset. So you can just simply think of this line as similar to those. Kaya lang, again, dire wala na ta gi-require pa nga mo download pa, and then pag mag-download, i-upload na pod, and so on and so forth. This is basically a way for us to make use of the existing datasets found in sklearn datasets na package. Okay, so third cell, ang ginabuhat nato dire, kani ato ang gitawag dire si load breast cancer na method. Okay? Mao ni ato ang gamiton aron katong unod sa dataset which has something to do with breast cancer related data, i-assign na to sa tuang object. So technically, kani ato ang breast dinhi, this is our identifier whenever we want to refer to the data that we have access coming from sklearn datasets, particularly katong dataset on breast cancer. Okay, so instead na magsigitag tawag kay load breast cancer from time to time, murabag gitawag nato siya kas ang iyahang returning value i-assign nato dire para later on ang atoan na lang buhaton is to reference to breast whenever we want to access the breast cancer dataset. Nya kung makita niyo ganina, kanang nigawas diyan na bunch, that's basically the type for our breast nga object. So it's a bunch. Unsa man ang bunch? It's basically mura na to siya maingon og ND array. No? So think of it as n-dimensional array. So makita man ninyo sa iyahang murabag some sort of description. Okay? Unya, if you are wondering what this actually contains, katong data nga gikan dire. So if we try to hover, makita nato nga it actually contains 569 records, and then naay 30 ka features, no? Kanang column din ha na kanang 30 nga naka-indicate din na, that actually refers to the number of columns or basically the number of features, no? So the next cell is basically trying to create additional objects that would refer to specific parts of the breast object. Okay, si breast man good contains all the data, the feature names, and the classification. By the way, si breast cancer nga dataset is ideal for classification. So kung naagianan ninyo somehow si classification sa inyong ML na klase, kasabot man ta, di ba, na pag mag-mention ta og classification, the goal of that task is given new datasets, meaning mga dataset nga pareha og features except that wala pa na-identify kung asa sila na class mabilong, ang task na to when we say classification is to assign appropriate classes to this new data set. No? Katong samples na to, by samples, pasabot na to ana record, instances, rows. Katong mga samples na to sa to ang new data set, which is again, wala pa'y classification, after feeding it into our classification model, ang i-expect na to nga output is all of those samples will be given appropriate class assignment. No? So, mahitabo na siya only after creating a model which actually learned from existing data set containing class assignments already. So, murabag ang dating, you have two sets of data. Pwedeng ang ato ang new data set mas gamay og number of samples compared to our training set katong ginagamit nato to build the model nya. Ang isa ka obvious gyud kayo nga kalainan katong data set na gamiton nato in building the model, in training the model, nato siya column na class nga naanay values na kabutang didto mag-agad actually ang pag-learn sa model. Katong isa pa ka data set katong gamiton nato later on for the actual classification nga task, walay unod ang class niya nga column. So ang task nato is to fill those with appropriate values gamit ang model. So maupod na kung mobalik ta diri sa to ang gina-present, isa sa mga columns nga naa aning data set has something to do with the classification, no? Kay kani nga data set looks into different features. Unya, ang classification is whether ang breast cancer ba daw is malignant or benign. Okay? So murag mao na ang gist sa data set. Kana tanan na information that is contained in this bunch kani si breast. So kaning next cell, ang purpose ani murabag tagi-tagihon nato. Nag-create ta og isa ka object si breast_data. Ang purpose ani gusto nato murabag if we are to think of it using an analogy, kato si breast mao ni ang tibuok na cake. So ang ato ang cake basically, pwede na ito siya bahin into several parts, no? Nya. Kaning first na to dire, kaning first na to nga bahin, particular lang yung kaayo ta sa data. So, slice na to ang cake, kuhaan na to siya somehow, katong pinaka-importante nga part sa cake, no? So, mo to ito ang slice niya, ibutang na to dire kay breast data. So, by doing that, napagyapoy na bilin sa to ang cake. Katong nahibilin, mao na po itong bahinon further, and that's what we actually do diri sa sunod na mga lines. Now, more technically, kaning breast_data, ang unod ani, katong particular part sa ato ang dataset nga, mo gito ang values. If we are to look at our dataset as rows and columns, di ba, aware man ta nga ang columns, ang pinakauna din hagid nga row, diha ginabutang ang ato ang mga column headers, or we call that as feature names, or simply variables or features. Muna, diha man na siya ginabutang. Importante man gud nga naapod na sa diha, ang kabalota, unsa ni atong ginatanaw na mga values per column. So pag minka og data lang ang ato ang try og access, you can eliminate the first row, the topmost row, kay mga strings man na sila representing the variables or the features. Kung scrap nimo to siya, what is left with you is basically mga actual na good na values per column. Mo to actually ang atong gina-access dire. Kaning breast, which refers to our bunch in cell number 3. Tapos, particularly, para maka-specify ta nga ang data lang atong tuyo, gitawag na to ang iyang attribute nga data. So, we do dot notation. So technically, murag ang pasabot, I am calling breast, the same breast that we have in cell number 3. Pero I'd like to be very particular. Ang akong gusto lang i-access sa breast na ko nga object is ang iyang data nga part. Kunya, i-assign na ko to siya sa kaninga bagong object. Okay? Nga na po na itong gibuhat pag-abot dire. We created another object, gipangalan na to siya breast underscore class. So, this has something to do with the class assignment for each sample in the dataset. No? So, diun sa pagkuha, still, gitawag na to itong ato ang branch, si breast. To be more specific, ang ako ang gusto lang kuhaon sa iyaha is ang iyahang target na attribute. And then lastly, nag-create ta og ikatulong object, gipangalan na tog features. This time, ang gusto na to i-point niya or gusto na to i-reference niya kay katong mga feature names nga makit-an na to kay breast. Now, para ma-picture out ninyo unsa na silang tulo kana si that data, si that target, and that feature names, we can actually ako ang gitawag si breast, the same breast nga naa diri sa ato ang previous nga cell. So kung makita na to, na siya description, okay, it's a breast cancer data set, na siya data nga part, which is, nara, okay, so naka n-dimensional array niya siya. So technically, that is 569 times 30. No? So 569 rows and 30 ka columns. Tapos siya attribute na feature names. So it's a one-dimensional array containing all the features, specific names of each column. Na siya attribute na file name and then na siya attribute na target. So kana si target, mao ni siya ang murabaog value assigned to each sample or assigned to each row, and these values actually indicate the two class values that we have. One is malignant, the other one is benign. No? So, mo na makita niyo 1 and 0 lang na. Kaya duha man atong ginapagpilian. Okay? So, kana sila, mo na itong ginatry na itong access dinhi. No? So, in our next cell, para lang masubay yun na to, if we were able to really get the correct values from our, what do we call this, from our bunch, i-print na to si features. So, this is actually the same with these features here. So, makita na to, nigawas tong one-dimensional array na to containing all the feature names, which is, kung inyong gitanaw pag-ayo, it's the same values that were displayed here. No? So, indeed, we were able to create an object called features, which is now pointing to these values here. Katong feature names. No? As demonstrated by the result of this print statement. Okay, and then the problem is, if you try to look into the features, it only considers those features that aren't necessarily containing the class values. Kung subayo ninyo, and kung ihapon ninyo niya siya, mo ni actually correspond sa katong 30, no? 30 ka columns or 30 ka features. Nya kay classification man ni siya, kani nga dataset ideal man ni siya for classification. Of course, naa kay isa pa ka feature or isa pa ka column din ha nga ang unod ana again is katong class nato. No, in our case, a 0 or a 1, which is unfortunately dili nato makita diri sa list of features. Obviously, because dili man gyud to sa feature, it's a label, it's a classification, no? It's just an extra column containing the appropriate classification for each sample or for each record. So dili gyud siya i-appeal dire. But because we wanted to treat these columns as one, ang next nato gibuhat is gi-append nato. So nigamit ta og ato ang kaugalingong term, ipangalan nato siya label. You can actually change that any way you want, pero again because of i-consider nato unsang appropriate nga term to refer to that last column, we made use of label. Pwede pud na nimo siya butang diha og class. It actually refers to the same thing, no? Unsa nga class ang naka-assign per record. So after appending, gi-attempt na to print balik tong features, the object that we created in the previous cell. So makita na to karon, it actually prints almost exactly the same set of values except that nadungag na karon ang label, the one we actually specified here. So from 30 columns, all in all, naana ta karoy 31 columns. O ni siya. Next cell, ang atong gibuhat, gisulayan na to print ang actual na values contained in the different columns, no? So, mao ni siya. Again, it's a multidimensional array in the sense that it has 569 rows and 30 columns. Okay? Yeah, mo na ang mga values. So the ellipses again indicate that there are more columns to show and there are more rows to show. Nga wala lang gipakita tungod kay limited lang man ang spaces na pwede niya kabutangan sa output. Nya, ang next na ito gibuhat, to really see if indeed we already have a way of referring to these different values in our dataset. Gisulayan na to, gitawag na to si breast_data, the same object that we just previously printed, no? So naay 569 ka rows, 30 ka columns nya. Gigamit na to ang shape na attribute, okay, para mahibal-an nato unsay shape. Pag may makag shape god, if we are to refer to NumPy's ND array, ang shape basically tells you the number of rows and columns if you are using it with a two-dimensional array. So muna, kung tanawin ninyo ang iyang output, it says 569 rows and then 30 columns. 569, which basically refers to the number of samples, the number of instances, the number of records, the number of rows. 30 refers to the number of columns, the number of variables, the number of attributes, the number of features. Okay? Now, you might ask, sir, anong 30? Di ba nagdungag na tag-isa ganina? We have just added label. Okay, you have to understand, si label, gi-add na to sa features nga array. Meaning, if we are to look at our dataset now, using the breast_data, wala niya ginamind actually ang katong mga feature names. Lahi ang array nga responsible sa pagtanaw ato nila. That's why, if you try to look into 30 columns lang gihapon, nga naman, maura man gyud na ang actual number of features, the one that basically describes each record in the dataset. So later on pa to nato gamiton tong ato ang features nga array and then para maisa na lang gyud nato sila tanan in just a single data frame. Ang sunod na to gibuhat after printing the shape of our breast underscore data nga array, si class na po atong gisilip. No? So, breast underscore class, giprint na to. So, you can see a one-dimensional array containing values 0 or 1. No? So, ang sunod na itong gibuhat, gi-perform na to ang pag-reshape sa ato ang sa tawag gani ang pag-reshape sa ato ang array because we have the intention of using that same array and to combine that with those data. Kato ganing gi-assign nato sa object na breast underscore data. Di ba kay two-dimensional array man to siya, na ay 569 ka rows and then na ay 30 ka columns. Kani man gud si breast underscore class nato, while it is an array, it's just basically a one-dimensional array na ay one row with 569 columns. So, the reason why we have to call reshape is for us to somewhat change the dimension of this array. When we say change the dimension, dili kay dungagan na to ang number of dimensions. We just basically would want to change the orientation. Imbes nga, naatay isa lang ka row with 569 columns, doing reshape basically tries to transform that one-dimensional array into 569 rows all contained in just a single column. Mo na actually ang ato ang gusto ma-achieve dinhi. Now, why are we doing that? Again, we have the intention of combining breast underscore data, a two-dimensional array containing 569 rows and 30 columns, together with si breast underscore class, which is now containing 569 rows and 1 column. Makita man na nato later on when we do the combination. Okay? So, just to check, after reshaping breast underscore class, di-print na to balik si breast underscore data just to see nga, wala pa gid nato sa gitandog. It remains to be intact. So, ang shape niya mo, gihapon, 569 rows, na ay 30 ka columns. So, ang sunod nga cell basically tries to combine the two. So, ang gigamit nato is ang concatenate na method ni NumPy. So, pag moingon ka og concatenate, gamit na siya aron masumpay nato ang duha ka separate arrays and just form a single array. So, this is a two-dimensional array. Katong na ay 569 ka rows. Okay, and 30 ka columns. Si breast underscore class is another array na ay 569 rows and na ay isa lang ka column. So, combining the two, basically, mao na nga to ang gipa-point karon kay breast underscore data. So, mao na kung imuha ni siyang i-hover, moingon na siya og 569 rows and then ang 30 nahimo ng 31. Okay, meaning na-update na siya. So, just to prove nga nausab na gyud nato tinuod, gitawag nato again si shape na attribute. So, ang giprint niya sa ato 569 rows and 31 columns. So, at this point in time, kana atong breast underscore data, that remains to be an array, not necessarily a data frame yet. No, two-dimensional array paghihapon siya. So, ang sunod na to gibuhat, gitawag nato tong constructor ni data frame. No? So, of course, we will have to call first PD as our alias for pandas. And then, Si data frame na constructor, a specialized method which allows us to create data frames. Unya, gipasa na to as argument ang ato ang array nga breast underscore data. So you have to remember, si breast underscore data nga array has been updated already. Thus, it now contains 569 rows. Wala inausab, but it now has 31 columns. So, ato ana siyang gi-assign sa ato ang panibagong object nga gipanganlan nato breast underscore dataset. So, kani si breast underscore dataset, this is actually a data frame and not an array. No? Makita nimo, instantiation man ni siya nga statement. Unya, ato ang gitawag to si breast underscore dataset, the data frame containing the combined 2D array of data and another array of the class values. So, as you can see now, natay several rows, 568 ang kinalasan niya nga index because nagsugod man tag 0, no? Kunya ato ang column pod na kita nato nga nagsugod siya 0, therefore it ends with 30. This column 30 here actually corresponds to the class, no? Katong label na ato ang gitawag ganina. Yeah. Because we haven't assigned actually the name of our columns, niingon dito naman tag data frame, no? So by default si data frame pag wala ka nag-specify gani og pangalan or tawag sa imuhang mga column, it makes use of a numeric name. So starting with 0 and then increments of 1. Nga na iyang gibuhat diha. So kay naaman tay features nga array which contains the 30 features plus ang katong label nato, katong ato aganing gisumpay. Gigamit nato to si features nga array and then gi-assign nato siya sa columns nga attribute sa ato ang data frame. So the same data frame nga ato ang bag-uhay lang tan-aw unsay unod, no? So si breast underscore dataset. Yeah, gitawag lang nato specifically ang attribute na columns aron mahatag nato tong ato ang array of features nga atong gi-create a little earlier, no? So, para ma-prove nato kung indeed na-replace ba gyud ang katong 0, 1, 2, 3, 4, and so on, o katong mga appropriate na column names, giprint nato balik ang ato ang breast underscore dataset, pero gigamit nato si head nga method. That's why you get to see only the first 10 records in the dataset. Asa gikan ang 10, nag-specify man ta og argument kay head nga 10. So it tries to print the first 10 records in the dataset. So as we can see, naanay appropriate names ang ato ang columns. No, medyo naanay idea nga, okay, kani siya yung column, mauday ni siya about. Katong zeros and ones man go, dili to ingana ka dali i-comprehend, especially in a human's perspective. Okay? So, mo na ito ang purpose nga pasa na to tong unod sa atong features nga array dito sa ato ang columns na attribute. Pag human-ana, okay, makita ninyo no, ang ato ang sa tawagan ni label kay numeric. So, wala gud na po'y problema. For as long as kabalot ta, unsay pasabot sa value nga 0 o unsay pasabot sa value nga 1. However, again, kay tao man ta, mas dali man gud ta makasabot, mas dali na to ma-perceive ang mga bagay-bagay kung it comes as a string. So instead of assigning it with zeros and ones or any number combination, nindot unta to kung naagi saktong label, no? So mo na ang next na to nga cell tawag, we just simply wanted here to replace all those zeros and all those one with a string value para mas dali siya basahon. Okay? So, zeros, mao to ang ato ang gipulihan og benign, and then all ones gipulihan nato og malignant. Okay? Asa dapit maadto? Of course, kay dili man tanan columns kinahanglan natong hilabtan or alisdan ang value, we will have to be very particular kinsa lang na columns ato ang gina-try og replace ang values. So, mo nag-specify nato inside the square bracket kining label. So, we are referring to the last column in our dataset. No? So, every time makita sa 0, pulihan niya og kaning string. Every time makita sa 1, pulihan niya og kaning string. Okay, so mao na siya. Now, to check, again, itawag ta og breast_dataset. This is our data frame. Pero kung tan-awon nato, we did not use head any longer. Instead, ang atong gitan-aw ang tail. So kung natay head, that gives us the first few records in our dataset. Napud tay actually tail na method, which does the opposite. It gives us some lists containing the records or samples at the end of the dataset. So, like for example, kanya itong gibutang dinhi, tail niya, man, nagpasa ta og argument nga 15. This means that we wanted to actually display the last 15 records in our dataset, which is mauna ni ang nigawas. Now, nag-replace tag values for zeros and ones. Tanaw na to karon kung nag-take effect ba gyud to siya. And as we can see, napulihan na sila. Now, all zeros have been changed to benign. All ones have been changed to malignant. Nya, asa ni sila gikan? If mo scroll ta a little bit, kung balikan lang nato tong ato ang breast_class, mauni sila. No? So if we try to count 15, most likely, maupod ni sila tong nakitaan nato dito sa baba. Only that, again, all zeros have been replaced with benign, all ones have been replaced with malignant. Okay, so mao to ang nahitabo. Excuse me. Nabay question so far, naay question si Mr. Prieto. Unsa ganitong target sa dili ba na siya column? Katong target, if you are referring to katong target gid mismo, the term target dito sa previous cell na atong ipakita ganina, that refers to an attribute. Okay? Pero kung sa dataset ta magtan-aw, ang pasabot atong target, katong column kung asa didto nato makita ang class assignment. So, for example lang if ang ato ang class has something to do with katong cancer na being malignant or benign, katong target, mao to ato ang way para ma-access tong column containing the values zeros and ones, which are representations of malignant and benign. Okay, sa original magud nato na dataset, zeros and ones magud ang nakabutang, dili gid tong word. Gipulihan lang to natong tuyo para mas dali nato siya i-interpret, no, as human beings. Na-answer ba nako ang question, Mr. Prieto? Okay, sige. So, any questions so far before ko mo padayon? Okay, dali lang ha, mag-andam lang sa ko dali o mag-refill kog tubig. Okay, walay questions? Baliktad, Mr. Ano, 0 is benign and then 1 is for, malignant is for 1. Okay, sige, so mapadayon ko ha. After replacing, again, ang ato ang gibuhat, giprint lang sa nato, balik ang ato ang dataset and just try to look into kung ato ba yun siya na-replace og tarong. Okay? Now, the next few cells has something to do with standardization, no, or standardizing the values in each column. So, unsay pasabot na to pag may taog standardize. Kung tan-awon mong good na to ang ato ang mga columns, naay uban din ha ang values less than 1. Kita ninyo, kani mga 0 point something. So, mura tag makaingon nga, it's basically between 0 to 1. Napoy uban columns din ha, nga ang values are actually more than 1. In fact, si worst radius, for example, makita nato dagko ang iyahang mga values. Worst texture, the same. Worst perimeter, the same. Worst area, the same. No? So, dili uniform ang scale sa ato ang mga values. And sometimes, this affects the quality of result our model could actually generate. So, ang purpose of standardization or ang pag-standardize is just basically to mura ba og try to transform these values into uniform scales. Okay, so kung may nga taog, the value should be something between 0 to 1, dapat sila tanan. Okay, so that's our way of actually standardizing the values. No? So kung makita nato, we just simply make use of an existing method. Okay? Again, under sklearn nga library. So naatay pre-processing na package which is, again, mao ni siya ang package nga naay collection of different methods, built-in methods that we can make use to do data pre-processing, no? And part din ha ang pag-standardize sa ato ang mga numeric values. So, nag-create tag object ni standard scalar. So, we are using standard scalar method. Okay, so according to its definition or its description, it standardizes the features by removing the mean and scaling to unit variance. Okay, the standard score of a sample X is calculated as Z is equal to X minus U over all S, where U is the mean of the training samples, or 0 if with mean na attribute sa ato ang pagtawag kay standard scalar, nag-specify ta nga false, and S is the standard deviation of the training samples, or 1 if with STD or with standard deviation is again set to false. Okay, so nag-create taog panibagong object and then gamit ang ato ang scalar, bali ang ato ang gusto mahitabo, standardize niya tanang cells sa ato ang dataset containing actual values. Of course, kung mapansin ninyo, ang reference nato nga gigamit is breast.feature names. Ngano man, of course, there is no need to standardize the classes. Kaya dili man na sila numeric to begin with. No? So, ang pasabot na to ani karon kani nga part dire gusto na to subayon tanan bahin sa atong dataset, of course, minus the columns, katong mga pangalan sa columns or katong mga feature names, and of course, minus the label column. So ang ato yung giapas din na katong mga columns kung asa didto nakabutang ang actual values for all the features that we have. Okay? And then, gamit si scalar na object, gitawag nato si fit underscore transform. So this is another method that will basically do two things. Na siya'y buhaton nga pag-fit and naapod siya'y buhaton nga pag-transform. So this is where the actual standardization is done. Okay? So, di-assign na to na sa balik sa ato ang X na identifier. Okay? So, since successful man it basically shows that all these values have been transformed successfully. Okay? Na-standardize na siya. So, ang next na to gibuhat dire, because of our columns, the actual columns of our dataset is named according to unsa gid na siya diha nga particular nga data. Ang atong gibuhat para mas dali nato siya ma-relate sa concept sa features, gipulihan nato tong mga pangalan ug laing pangalan, laing tawag. Okay, so we made use of the prefix feature and then depende kung ikapila siya sa list of features, gisumpayan nato og number ang katong prefix na feature. So that's why if we try to read this one, okay, katong features, ang mugawas na diri karon sa ato ang bagong data frame, feature 0, feature 1, feature 2. So basically, these are the same features na ito nakita dire. Feature 0 probably refers to our mean radius. Feature 1 basically refers to our mean texture and so on and so forth. No? So mao na ni sila. Okay, and then if you try to see, these are the values originally indicated in our data set. So for the first column, kay mean radius, mo ni ang mga values. But because we did some standardization, makita nato nga, for the same rows, nanay kausaban sa values nga, makita nato sa tuang data set. Okay? So karon nga, na-standardize na nato ato ang dataset. What we lack so far is the actual implementation of PCA. No? So, the next few cells are actually dedicated for doing the actual principal component analysis. No? So, sa giingon ako sa inyo ganina, pag maingon kag Python, especially if you are to utilize sklearn, since it's really a rich collection of different packages, different built-in methods, different built-in classes, ideal for machine learning and data science and data analytics. Dili na gid nga na ka lisod ang pag-perform or ang pag-implement sa PCA. Though, kanito ang ginabuhat manggod pod is just basically scratching the surface. Dili pa manggod pod nitong power kaayo, no? Ang point raman nato dire is somehow ma-demonstrate nato that based on the concept as demonstrated in the video that I asked you to watch, ma-implement nato siya into an actual Python program, no? So, ang kaning ato ang cell na ginatan-aw karon, this is where we actually implemented PCA. So, itawag na to balik si sklearn, and then we made call of another package And then from that package, gitawag na to si PCA. So PCA basically is a built-in method who will be responsible in the actual performance or the actual implementation of principal component analysis. Okay, and then naatay object na gi-create si PCA underscore breast. And then i-instantiate na to ato ang PCA breast to be an object of this. And then nag-specify ta sa sulod sa ato ang PCA na method sa number of components, no? So mo na gitawag na to ang attribute na n underscore components, and then we specified the value 2. Okay? Tapos kani karon ato ang principal components underscore breast. This will be our object to hold the result of this one. Okay? Okay. Kung kahinumduman ninyo sa atong gibuhat ganina, the fit underscore transform method is the actual method that does the real thing. Okay? So, siya ang mo perform sa pag-fit and at the same time sa pag-transform. Later on in the demo number 2, makita nato nga the approach is a little different because we made use of the separate fit and the separate transform methods, which is maura gud gihapon to ang ginabuhat ani, giisa lang diri sa kaning method ang pag-perform sa fitting and then ang pag-perform sa transformation. Okay? So makita ninyo based on the description, for this particular fit underscore transform nga method, this is to apply the dimensionality reduction. So ningon siya diha, fit the model with X and apply the dimensionality reduction on X. Okay, so mo na iyang ginabuhat. So this is the actual method who is responsible for the dimensionality reduction. Ang result ani nila mo'y atong gibutang diri kay principal components underscore breast. Okay? Unya, kung kahinumduman ninyo, we already have this frame. No? Makita ninyo sa ganina. This is a newly created frame. Nag-create ang bagong frame, gipangalan na to principal underscore breast underscore frame, just to simply denote that this frame contains values that have been generated after performing the PCA. No? So, kita na to, gitawag na to si data frame na constructor, gitawag na to ang attribute nga data, ang gipasa na to katong resulting value coming from this one here. Okay? Si principal components breast. And then of course, ang ato ang columns, i-assignan pod na to og column names or identifiers. So, katong display na nato si principal underscore breast underscore frame, which is a data frame, makita nato nga natay duha ka columns. We have principal component 1 as our first column, and then we have principal component 2 as our second column. Okay, and then makita ninyo for each sample in our dataset na ay value nga na-generate dinhi. So, if you could still remember katong dito sa video nga inyong gitanaw, di ba? Each data represented by the circles in that visualization will have to be projected to the line representing the principal component. Ma-remember ba na ninyo? Nakuha kaya ninyo na nga part dito sa video? Okay, kaning mga values din hiba, if you are wondering what are these, muna nanguntahan ako, if gisabot ninyo og sakto tong video, isaysay dito sa video nga, na mga computations sa kinahanglan buhaton. So, to be able to do these computations, kada data, which is represented by a circle, dito sa demo ni atong ginistoryahan, I mean sa katong video na atong gipakita, diba, demonstrate niya by plotting 6 different data values, no? So, ma-remember niyo na yung mga circles, katong green circles na iyang gigamit to represent each data. So, as you create n number of principal components, in our case, duha ato ang gi-create, katong data, which are represented by the circles in that plane, in that visualization, di ba gi-project siya sa line? Katong line, katong imaginary line, that's actually the representation of the principal component. Yeah, importante to siya i-perform tungod kay we are to come up with the explained variance towards the end of the PCA. Okay, so i-explain na niya somehow dito sa video what is explained variance and how it is actually computed, no? So daghang proseso na magian, but in our case here, gitawag nato na actually built-in na kanang attribute wherein we can actually see the resulting explained variance. So natay makuha diri nga numeric values. Kaya lang diri naka-decimal format siya. If you could recall dito sa video na inyong gitan-aw, nasa katong gipang-mention gani nga percentages. Like for example, depende sa number of components na amuhang gi-consider, each component basically will result to a certain percentage for the explained variance. So I hope ma-recall ninyo to sa video, no? So kani nga line, kani naa diri sa to ang cell na ginatan-aw karon, this is actually the same thing, no? Only that this is represented not as a percentage but as a decimal value. So pwede ra pud gyapon nato ni i-translate as 44% and then the other one is approximately 19%. Okay, nakuha ba? Okay, so padayon ko ha. Ang next few cells are just a repeat of what we actually did, no? Makita ninyo. Kaya lang, try na to og increase ang number of components. So as you can see here, in our next example, giset na to ang n underscore components na attribute into 5. All the other parts of the codes are pretty much the same based dito sa to ang tanaw na ganina. Yeah, kay 5 man ka principal components atong gina-expect na ma-generate or ma-generatan og values. Gi-indicate pud nato na natay 5 ka columns sa to ang gi-create nga data frame. And as we display it, mo ni ang mamahimong kinalabasan niya. Okay? Tapos, of course, we did the same. No? So, gitawag na to si attribute na explained underscore variance underscore ratio underscore. So, gawas, these values here, again, represents the explained variance score for each component. Yeah. Kita ninyo, si component 1 o si component 2 as demonstrated earlier, na ay values nga 44% and 19%. All the other components are way lower compared sa ilahang duha. Okay, so muna siya. And since I am handing you this notebook, later on, if you are interested, you can explore on the number of components that you can actually create from your dataset. Tanawin ninyo, depende sa inyong pag-explore sa number of components, look at the resulting explained variance score. No? Usually, good. Usually, meaning dili sa tanang higayon, it's the first principal component that will have the greatest explained variance score. Okay? Na yung mga instances nga dugol na sila, but most of the time, okay, si PC1 or atong principal component number 1, the first principal component that we will have usually bears the greatest explained variance score. So explore na lang ninyo later on what if i-change ninyo into a higher value ang kaning n underscore components or the number of components. Okay, question so far? Naabay mga pangutana? Asa particularly na part, Ms. Villa Flores? Okay. The explanation of the explained variance, pwede ninyo i-refer balik dito sa video kay mas detailed iyang explanation sa explained variance. But if you try to define explained variance, this has something to do with how much each principal component is accountable for the variance that there is in your data. So moto nga, it actually gives us percentages. No? So sa ato ang gi-demonstrate, first, the first principal component accounts to 44%. The second one accounts to approximately 19%, and then the rest of the principal components, kato si 3, si 4, o si 5, accounts to a lesser percentage. Okay? Mo to gagmay ang ilahang explained variance score. Okay, any other questions? Naipangutana? Okay, if wala, so let's try to look into the second demonstration. So kung tanawon natin yung second demonstration, this is almost exactly the same, except that it uses a different data set. So kani nga data set contains images. So this has something to do with analyzing a certain image, whether it is any of the 9 10 digits that we have, 0 to 9. No? So, kung subayon na to sa kaninga cell, dili na to gikuha gihapon, no? Just like what we did earlier sa ato ang demo number 1, we made use of sklearn datasets na package, and then from here, nanawag taog method, si fetch open ml. Okay, and then pagtawag na to sa method, as we instantiate a new object, ipasa na to ni kaning value diri sa sulod basically refers to the actual dataset that we want to call and pass to the dataset object. Kanya, ang next na shell, kani ang responsible sa pag divide sa dataset, katong original dataset, the one that we were able to generate through this line here. Kaning third, mo ni responsible sa pag-divide. When we say divide, ma-remember ninyo katong discuss na to somehow tong concept sa data pre-processing. Towards the end, i-explain na to nga. Isa pud ka importanteng part sa pag-prepare sa ato ang data before the actual analysis is by creating or by splitting our data set into several smaller data sets. Ang purpose, para nakay gamiton for training, nakay gamiton for validation, and then nakay gamiton for testing. No? So, mo na ang nahitabo dire. Gamit ang train, test, split na method. So, ang purpose ani is bahinon ang dataset into training sets and test sets. Unsa may pasabot ana? Usay man gud, as we create models, wala pa mangyud kay dataset na katong raw, wala pa'y class. Okay? So, murag ang mahitabo ba, if you want to test your model whether it's really good in, for example, classifying the different samples in your dataset, wala man kay actual good na dataset nga magamit kanang something that is new, something that you haven't seen so far, ang pwede na to buhaton, dito ta manguha sa ato ang dataset gyud katong gigamit na to originally. So mo na nga, before pa man ka mo perform sa actual analysis sa pag-build sa model, bahino na nimo daan imuhang dataset. So kintahay ang imuhang dataset na kay 1,000 ka samples, 1,000 ka records, 1,000 ka rows. So what you can do is actually split this into 2 or into 3. So 2 kung gusto nimo nga test and train lang. 3 if you want to split it into train, validation, and test. Usually, ang mga tao would just settle with 2. No? Importante na kay train set and na kay test set. So, sa tuang scenario, if I have 100 records with my original dataset, pwede na ako bahinon into 80% i-allot na ko for the testing, for the training, and then the remaining 20% gamito na ko for testing later on. So, unsay siste? This is in the case of a classification task. Katong 1,000 ka records, tanan to sila, naana to sila yung value sa class na column, sa label na column. Meaning, each record naanay class assignment. No? So in our demo 1, 'di ba, nga to ang dataset kay breast cancer man to, basically i-classify kung malignant or benign. If we are to use that as reference for the 1,000 records we are talking about, isipan na lang ninyo nga tanan 1,000 records na assignan na og class. It could be malignant, it could be benign. So nanay classification tanan. Kaya lang, again, tungod kay wala man gud tay panibagong dataset, similar og structure atong dataset na atong nakita or ato ang na-acquire, except that blank ang iyahang class or label na column. Dito na lang ta manguha sa kung unsay available sa atua. So katong 80% na atong giingon, that's basically accounting to 800 records, gamiton nato sa training. Katong mahibilin nga 20% or katong 200, i-reserve na to siya later on for testing. So unsay mahitabo? Since naaman to siya label na daan, naaman to siya value for the class column, you just simply remove those values and let the model identify the classes for those 200 records. Murabag, kabalo na ka, unsa gyud ang ilahang correct na classification. Kaya na-classify naman sila before. But for the purpose of testing your model, whether it's actually able to determine the appropriate class, tuyoon ni mo tog tanggal ang mga values nga naa didto sa class or label na column, and then you let your classification model fill those empty cells with classification values. So siya na mo ingon kung kani ba si record 801 benign or malignant, si 802 benign or malignant. So assignan niya isa-isa. Nya para ma-test na to later on kung sakto ang iyang gibuhat, meaning unsa siya ka maayo in terms of classifying each record, ikumpara tong list of classifications nga na-identify sa model versus katong actual classification ni records 801 until records 1000. So, mura bag ihapon, pila kabuk didto ang tama ang pagka-classify, pila didto ang mali ang pagka-classify. And that basically can be used later on to determine how good or how bad is the model in identifying the correct class. Okay? So, ingana ang ihang dagan. So, kani karong makita niyo nga train test split, ang purpose ani is katong pagbahin sa dataset into subsets. Okay? Nga. Makita ninyo na ay upat ka objects nga ato ang gi-create, no? So we have train underscore image and test underscore image. This has something to do with the actual features. Okay? So katong tanang features gibahin into tanan records for all those features gibahin into train set and then test set. Okay? Yeah. Of course, features man tatong gisuryahan din katong mga columns nga nagatabang aron ma-describe og sakto ang kada record or kada instance or kada sample. Kaning third and fourth objects, ang purpose pod ani is bahinon ang katong label nga column or katong class nga column into train and test. No? So, if we are to go back to our previous example, tayo kung dili ta mo tan-aw sa ato ang breast cancer nga dataset, ang gibutang nato didto sa train underscore img and test underscore img, ang mga values contained in all columns except this last column. Mao to'y naa didto sa train underscore img and then test underscore img. Nya katong sa train underscore lbl and test underscore lbl, wala na pud siya pakialam sa katong ubang columns. Ang iya lang, kanina lang label na column. Nya gi-divide lang niya. Some percentage mo adto sa train set and then some remaining percentage mo adto sa testing. Mo to ang nahitabo dito sa train test split. Okay, and then si standard scalar gitawag na pud nato balik again for the purpose of standardizing our values, no? So create ta og panibagong scalar na object, the object that will be used to refer to the standard scalar na method. Okay? So kani akong ginaingon sa inyo ha ganina nga we actually made use of a different method nga fit o method nga transform. In a way, this relates to the fit underscore transform method identified earlier, except that si fit, ang iyang trabaho is just to fit. Okay? After niya mabuhat iyang responsibilidad, wala na siya pakialam asa to nimo i-implement ang katong imuhang gi-fit nga model. Okay? Whereas si transform, dili pud siya ang responsible sa pag-fit. Ang iya granting na naanay fitting na nahitabo, I'll just do the transformation. So, kaning two separate methods, fit and transform, giusa na sila dito sa fit underscore transform nga method. So, you have the option to either use the fit and transform method nga separate or simply use the fit underscore transform nga method nga nakaisa na lang. Okay, at the end of the day, you will arrive with the same output man. Provided nga sakto ang pagkatawag sa fit o sa transform, katong separate na mga methods. Okay, and then, nagtawag ta og PCA balik. Tapos, igamit na to si PCA na object so that we can again perform fitting and then transforming. Diri na ang actual nga pag standardize. Katong pagtawag nato kay transform nga method. Okay? And then, after this cell, actually, humana na ta if ang ato ang concern lang gyud is the actual, ano sa tawag ani, the actual dimensionality reduction. Dili ra nataman. Kaya lang, again, mato kong gingon sa inyo ganina, for demo 2, gipakita niya further how we can actually do classification using logistic regression nya. Ang gigamit na to nga dataset, katong dataset nga niagi na og principal component analysis. Sa first demo manggod, ang emphasis is just just reducing the number of dimensions. Bahala na lang kung gigamit ba gyud nato tuod ang katong transform dataset or wala. Sa demo 2 nato, gipakita niya nga ang katong na-transform na nga dataset after doing PCA, mao na to actually ang gigamit in the actual creation of the model and then of course in testing the model. Okay? So, kani diri na part kung dili pa ninyo completely gyud mag-gets, ayaw ra sa na in-mind, we have a dedicated meeting explaining classification task, no? So, agian nato ni balik ang ato ang di-provide nga sample, no? Kaning notebook nato ang naa karon. But you can just run. Wala may problema. Pwede niyo na siya i-run. Kaning output, kining kinalasang output, this has something to do with how good is the model in identifying the appropriate class for the records that were tested. Okay? So, mo na siya. No, so basically, demo 1 and demo 2 shows how PCA are implemented in Python. No, so sama sa kong gingon ganina, dili gyud necessary nga manumunuhon gyud og taman og compute atong mga values. Though pwede gud nato to buhaton, pero dili naman good pod siya ingana ka sensible kay dili man kana atong gi after. What we are after is to make use of the built-in methods nga naa na daan kay sklearn nga library para pod ma-simplify ang mga bagay-bagay. Okay? So we are done with dimensionality reduction. Naabay question. By the way, klaruhon lang nako, that is just one technique ha. There are other ways of doing that. Others are way complicated than what we just did. So you can explore if you wish. But at least kato-ato ang gi-demonstrate karong hapon, that can actually suffice if we have the same concern with our dataset. Kaya di ba sa ako ang giingat po sa inyo ha before, magdepende man yun ang mga steps na itong kinahanglan buhaton sa dataset nga naata. Any questions? Walay pangutana? Okay, sige. So kung wala mo padayon ko, but I'll be presenting a different tab. So time pa usa ako ang i-change. Okay, pa-confirm lang ko palihog if you are now seeing my screen. Now, I am actually sharing a particular tab. Again, still part of data pre-processing, perhaps the last part of data pre-processing. Makita ba? Okay, thank you for confirming, Mr. Gomera. So, unsa man ni ato ang notebook nga ginatanaw karon. So, di ba gi-explain nato last time nga ang ato ang features, again by feature we are referring to the attributes for our data set, the columns, okay? This can be classified into either categorical or numerical. Okay, so pag may categorical, na ay mo ra ba og predefined set of possible values. Pag may numerical, these are usually numeric values. Pwedeng integer, pwedeng na ay decimal point. Depende kung unsa pod ang data gid natong gikinahanglan. Now for categorical, mabahin pa gid siya further into ordinal and nominal. Okay, if you could still remember that one. So, manong importante nga masabta nato ni siya. Pag maghiskot man gud tag feature encoding, ang murag pinaka-goal nato ba is to do necessary transformation, especially for features that aren't that easy for our machine to interpret. Unsa atong ginapasabot ana? 'Di ba? Na may mga cases nga ang ato ang dataset would contain features that are not necessarily numeric. Kanya pag mayong ka computer, it best work if the data that it tries to process are numeric in nature. So, mo na nga manginahanglan ta mo perform og some sort of transformation so that these features in our data set, which are non-numeric, we are referring to the categorical features, ma-transform na to siya in such a way that it is represented by numbers, yet the thought of it remains the same. Diba kay, again, ang ato ang machine manggod, it works better if the data that it tries to process, it tries to analyze, is in a numeric form. So, mo na ang pinakamurabag gist sa ato ang ginatawag na feature encoding. Basically, a process of transforming our non-numeric features into its numeric representations. Okay? Nya ang focus nato karon categorical features. Okay, possible man gud pod mag-perform ta og feature encoding transforming numeric numerical features into categorical. Okay? So ang ato ang i-demonstrate karong hapon categorical features transformed into numerical. Okay? So ato ang subayon ang ato ang notebook. Okay, so sama sa naandan, magsugod ta sa pagtawag sa mga importante nga libraries and packages, no? So we make use of pandas, numpy, and copy. Copy because we will be calling later on a copy method which will allow us to create copies of our data frames. Explain lang ako na later on nganong kinahanglan na siya. Okay, so far wala siya problema. So I'll just have to tama ako ang gina-open, no? So this is sa initial exploration. So this has something to do with reading the data set, examine the data set, and then try to do some initial exploration. Okay, so familiar si read_csv. So katotong naandan, gigamit nato si read_csv for us to be able to import a locally stored CSV file or text file, no? Locally stored in our machine. So it's also possible to actually call read_csv and pass to this method a URL of an existing CSV file or text file. Sama sa kanya to ang gipakita karon, no? So after calling read_csv, katong data nga iyahang nakita from the URL that is given, gi-assign niya sa flights na frame. Okay, so we actually have here a data frame, gipanganlan nato og flights_frame. And then just to see what this data frame contains now, tawag nato siya balik, and then of course ang ato ang head nga method muhatag sa to sa first 5 records. So, makita na to naatay several columns, no? It's a combination of numeric, it's a combination of numeric and categorical. Okay? So kana siya. And then to see the actual types for each of the columns that we have, gitawag nato si data frame and then gisumpayan nato sa method nga info. So this method actually prints a concise summary of a data frame. When we say prints a concise, ang pinakamurag gist gyud niya ani is to murabag give us an information of the data frame that we are examining. So unsa namang information ang iyang ihatag? Of course, the number of records, Okay, the number of columns. And then, for each column, ipakita niya kung unsa ang data type. Is it non-null? Okay. And then, bilangon niya pila kabuok ang mga non-empty cells for each of the feature that we have. Okay. Ang particular column name or the feature name, kita niya. And then, ang tumong nato dire, ngano ginatanaw nato ni siya, is for us to see what are the data types of our columns. Okay, so it's basically a combination of int, float, and object. So based on this information, we can presume that columns having the object data type are likely to be categorical. No? Are likely to be categorical. Now, ano ta maingon nga likely? Wala man gud po'y assurance. Not because other columns are technically numeric ang ilahang data type. Like in the case of month, naka-int na siya. Day, naka-int na siya. Pero if we try to examine, possible man pod ang month mamahimong categorical. Kaya lang, it's best represented if mugamit ta og integer na data type. So, mo tumayin ko nga, pag object ang data type ana imuhang column, it's likely to be categorical. No? So, we have columns carrier, tail num, origin, and destination as objects. Okay? So, ang next natong buhaton, nag-create taog panibagong frame. Actually, gi-recycle lang na to ang atong identifier, the same identifier na atong gigamit diri sa ibabaw. Except that, niingon tag nag-create tag bagong data frame tungod kay we intentionally get rid of those columns that are non-object. Kay dako man gud ang chance nga numerical gid to sila and dili man sila kato ang atong giapas. Okay? So giunsa na to pag create sa bag-ong data frame. Of course, gitawag na to ang ato ang original data frame containing the original before siya gipasa diri sa ato ang assignment operation. The original data frame containing the 16 columns. Kaya lang particularly giselect nato ang mga columns nga nakasatisfy aning select underscore data types nga method. Okay? So, niingon man ta dire, we only would like to include all those columns which have an object data type. Okay? So, ang nahitabo karon, the flights underscore frame, okay, after filtering, katong object lang ang data type, i-assign na to balik kay flights underscore frame nga data frame. So, ang nahitabo, in the next cell, makita na to nga, upon printing, ang nahibilin na lang ng mga columns, mao na lang ni. So, we have carrier, tail num, origin, and dest. Balik ta ganina, these are the same columns wherein ang ilahang data type nga nag-reflect diri sa info nga method object. So natay upat. Okay? So muna. Next, ang atong gibuhat, gi-try na to og tan-aw naabay mga missing values sa ato ang dataset. Considering nga ang atong dataset upat na lang ka columns ang nahibilin. No? So we were able to do that by calling the isNull method. Again, ang iyang purpose is mo evaluate sa imuhang data frame para ma-detect niya kung naabay missing values. Okay? Yeah. With these additional attributes, na that values, it tries to look into all the values contained in the data frame. Dili lang specific column. In fact, tanan values nga makita niya in the data set. No? Nya. That sum, because again, ang purpose manggod nato is just to basically come up with a single value. So, mo na, ang iyahang result, ni print ang 248. So, it simply means na ay 248 ka cells sa ato ang data frame nga walay valid nga value. No, na-detect siya ni ISNAL as missing values. So, the next cell, we just simply remove the that values attribute para makita nato asa nga particular column makit-an tong mga missing values. So, it turned out that of the 4 columns that we have left, sa tail namta actually na ay mga missing values. Okay? Dere. So, all the 248 identified missing values in the previous cell belong to tail num. So, unsa karon ang atong pwede buhaton? Remember, this is an issue of missing values. Okay? Something that we need to address as part of quality data assessment. No, na yung mga missing values. And if we see tail num as an important feature, we just don't simply drop this column or drop this feature. Instead, we can actually do a replacement of the value. No? So, ma-remember ninyo, isa sa ato ang gibuhat previously is to replace all the missing values with a valid value. Either we choose a particular value that best describes the originally missing values, or we can rely on mean, median, or mode for the value to be used as replacement. So in our case, we make use of mode. Again, mode ang ideal because of course we cannot perform mean, no, with a categorical feature. Okay, especially that this is an object. So dili nimo na basta-basta ma-computan og mean. Instead, ang atong gigamit dinhi is ang mode. When we say mode, the most frequently occurring value in the column or in the feature. So before nato gipulihan, ato sang gisubay unsa di ang mga unique values that are contained in the tail num column. So mo ni nakalista na diha tanan. There are 3,022 unique values for the tail num column, and then mo nang ilang bilang. So kaning pinakauna obviously refers to the unique value that is most recurring. Therefore, mo ni siya actually atong mode. So gamito nato ni siya nga value aron mabutangan nato og value tong 248 na ato ang na-identify ganina. Okay? So how do we do that? Again, mogamit ta og fill na. If you could still remember, ato ana ni siyang gibuhat before in dealing with missing values. So unsa ito ang gi-assign sa iyang nga value because technically kaning open and close parenthesis nato dinhi mao man ning kinatibuk-an ni fill na. So ang question din ha, unsa ang ato ang gihatag nga value sa iya. So katong ato ang flights underscore frame tail num that value counts kani, pero specifically the first value lang. Isa naman atong pwede i-assign, no? So kani nga part will give us an array. Mo ni ang unod sa array. And by adding index is equal to 0 or index square bracket 0, we are actually just accessing the first element of the array. Kani. So mo to siya karon ang gigamit to replace all those missing values. Now, to check kung naabag yung na-perform or naabag yung replacement nga nahitabo, gitawag na to balik si flights_frame is null.sum. Makita na to karon si tailnum nga naay 480 something ganina, 248 ka missing values, nag-zero na siya karon. So technically, na-replace na nato to tanang missing values with appropriate values. No? Yeah. If we want to explore on the other columns, like for example, kung gusto ta makahibalo, pila ka buok unique values under the carrier feature. So same lang, gitawag nato si value counts. So these are the unique values. And in this column, makita nato unsa kadaghan ang instances for these unique values here. So ang ato ang AS mao'y pinakadaghan, followed by WN, followed by OO, and so on and so forth. Okay? So you can also do that for the other columns. Naman tay upat if you want to determine unsa ang unique values nga makit-an sa origin nato nga column. And if you want to also see the unique values na makita nato sa ato ang desc nga column. Okay? Pwede niyo na siya tawagon usab. Kini. You just replace this part of the code para maka-specify ka unsa nga particular column imong gusto tan-awon. Okay? So, kana siya. Now, if we are done with our exploration, by the way, pwede ka mag-add if you want to include some visualizations, pwede nimo ni i-plot. Okay? Pwede man nimo gamitan og bar charts para makita nimo visually ang distribution sa number of records depende sa imuhang carrier. Okay? And then you can do the same for origin and destination features. Okay? So, good na ta sa atong initial exploration. Proceed ta sa actual feature encoding. So, there are a lot of techniques. I just basically identified some. No? So, dili pa yun niya ang kinatibuk-an nga pwede nato buhaton or sundon na technique. There are other techniques out there that we can actually use. No? So, kani nga technique, ideal pud ni siya for categorical features to be encoded into numeric. No? So we have the simplest, meaning we just simply replace the values. We can do encoding, and then we can also make use of one-hot encoding. Okay, so muna itong i-demonstrate sa mga nahibilin nga cells. So let's start with replacing values. So to replace our values, we can actually make use of a dictionary. So, sa ako ang gi-explain last time, no, pag may kag dictionary, it actually contains a list of values, a combination of a term and its corresponding value equivalent. Kaya lang, kung tanawon na to ni ato ang dictionary din, this is actually a nested dictionary. Nga naman, a dictionary is always contained in a pair of curly brace. And by looking at our dictionary here, we can actually see a nested curly braces. So, ano nahitabo dire? The outer dictionary contains just a single value, si carrier, muna ang ato ang term, and then, for its corresponding value equivalent, kaning kinatibuk ang inner dictionary. Now, how can we say that this is a dictionary? Of course, we can see several values as indicated by our comma. Comma man ang atong separator for each value in our dictionary. So we have our term, double A. So ang iyang value equivalent is ang 1. We have the term AS, ang iyang numeric value equivalent is 2. We have B6, equivalent to 3, DL, 4, and so on and so forth. So, pag mayroon ka og replacing values using a dictionary, ikaw ang makabuot unsa nga numeric representation imuhang gusto gamiton for each unique value in that particular feature. So this is our feature. These are our unique values for that feature, and then kanang mga numbers din ha, muna itong mga numeric representations na gusto natong i-assign as replacement to these non-numeric values. So, tanan AA pulihan og 1, tanan AS pulihan og 2, tanan B6 pulihan og 3, and so on. Okay, so if we are to replace the values using this approach or using this technique, you can always specify the numeric value you want to replace your non-numeric values. So, pwede, kung gusto ka, di ka mag-start og 1, pwede di mo butang diya 1,000 followed by 1,001, 1,002, 1,003, 1,004, and so on. Pwedeng 10, 20, 30, 40, ikaw ang magbuot. Basta kay aware ka nga kanang value nga 10 that corresponds to the original value AA, kana si 20 that corresponds to the original value na AS, and kana si 30 corresponds to the original value nga B6, and so on and so forth. Okay? After creating your dictionary, you just simply use the replace method. No? So, unsa ato ang gibuhat? Una sa tanan, nag-create sa tag-copy because we don't want this flights underscore frame, the original data frame that we used earlier, dili na to gusto nga ang iyang original value matandog. No? So, we created several copies. In the succeeding cells, makita na to nga every now and then nag-create tag copies. Again, to avoid altering the original value of the frame. Okay? So, flights underscore frame dot copy creates a copy of this data frame, of course, including its values, the feature names, and so on. Gi-assign na to sa panibagong object. Okay? So, another data frame. Gipanganlan na to flights underscore frame underscore replace. Okay? So, unsa itong gibuhat? Here, we call our data frame. Gisumpayan na to sa replace nga method. So, unsa ginabuhat sa replace na method? Replace values given in to replace with a specific list of values. So, kaya nag-create naman tag dictionary in the previous cell, we can just simply make use of that dictionary. So, unsay buhaton ani niya sa dictionary nga atong gipasa? Pagtanaw niya karon sa ato ang flights underscore frame underscore replace nga data frame, ma-realize niya nga naay upat ka columns. Ang matag column naay column name. So, ang una niya buhaton, pangitaon ang particular column as indicated by this value here. So, naiupat ka columns named carrier, tailnum, origin, and dest. But because we were clear that in the replace map dictionary that we created, we are only interested in one column, si carrier, maura pud to iyahang pangitaon ug mao to iyahang i-attempt og replace ang values. Okay? So, in place is equal to true, meaning whatever changes we introduce using the replace method will actually be executed and implemented, hence doing the changes in the data frame. So as we can see, ato ang carrier na column karon have already been replaced with numeric values. Asa gikan ang numbers katong sa dictionary nga atong gi-create dinhi. No? Mao na ang nahitabo dinha. Okay, so if you opted for a different numeric values, of course, mao po ito i-reflect niya dire. So, giunsa na to pagkabalo nga tama na sa looking at our original data set, tanawon na to ha. Naman tay, if I'm not mistaken, naman tay sample ganina. Nara. The first 5 has the following carrier: AS, US, UA, US, AS. Okay? So, AS, US, UA, US, and then balik og AS. So, tanawon na to. Sa to ang dictionary nga gibuhat, AS is 2, US is 9, UA is 8. So, check. AS, correct. US, correct. UA, correct. US, correct. AS, correct. Therefore, nasunod gyud to ang ato ang dictionary nga gi-create. Okay? So, to further validate kung napulihan na ba gyud ang ato ang carrier na column, gitawag nato ni nga attribute si dtypes para mahibal-an nato unsa ang data type na karon sa ato ang carrier nga feature. Okay? So, ang iyang output is int 64. Obviously because integer values naman ang naa diri sa ato ang carrier na feature or column. Okay? So, that's basically one. Now, to demonstrate label encoding, naasa tayo kinahanglan buhaton because the method that we will be calling later on will require these changes. So, unsa tong changes na itong ginaistoryahan? For some built-in methods to take effect, there is a need for us to cast categorical features from being object, we are talking of data types, into category. So, we can do the casting using the as type method. So, unsa ginapasabot ani ato ang duha ka linya dire? Una, nag-create sa di tag copy. Again, para dili matandog tong original nato nga flights_frame. So, unsa atong gibuhat? Sa kaning bagong data frame nga atong na-create, gitawag na to ang particular na column, carrier, and then, we would like to replace this one with whatever we are able to come up here. So, unsa na diri sa pikas diay sa right-hand side sa atong assignment operation? The same, flights_frame_copy, and then carrier. Pero, gisumpayan nato og dot as type category. So, unsay pasabot? The original data type of this is changed the moment we made use of the as type method. So, from the original object data type, gipulihan nato siya og category. Okay? The same is true with the origin. Gitawag lang nato si origin and then that as type. So, unsaon nato ni pag prove. So, we can just basically call flights_frame and then copy. Tapos, if you could still remember, natay info nga method. So, si info na method karon will basically try to change object type to category. Now, makita nato nga only one of the two lines were successful. Ano man? Again, ang expectation manggod ani naka-object. But because we have just changed our carrier into its numeric counterpart, ang atong original nga object nahimo ng integer after this line here. So, calling this 2, while it is actually syntactically correct, wala may sayop no sa syntax, makita man na ninyo kay ni execute man, ang nag-take effect lang diha actually is ang atoang second line. Again, why? It's only origin of the two lines that we have specified. It's only origin that is originally an object type. So, sa iyahara nag-take effect ang pag-change from object to category. Si carrier na to, being an integer, wala na siya gyud na usab. Okay, wala siya nahimong category. So kani siya nga line, additional na lang nato ni para lang ma-prove nato kung tuod na change ba nato ang nahibilin. Okay? Ang katong objects na atong gitawag. Okay, so after doing so, delete ko lang nigbalik, perform ta og label encoding. So unsa ang nahitabo dinhi? For label encoding, we just simply called attribute cat encodes. So katong ato ang data frame nga si flights underscore frame underscore copy. Yeah, specifically for the carrier feature, mo na ginapasabot ani ato ang square bracket dinhi. We just simply added the attributes cat encodes. So unsa iyang ginabuhat? It tries to examine the original values of the frame and then assigns a numeric equivalent for these values alphabetically ordered. Meaning, di ba kay kung tan-awon na to ang ato ang carrier, originally, masort man ni nato sila alphabetically because our carriers are actually strings. So, katong original nato, okay, tara, mo ni sila, if isort ni sila alphabetically speaking, ang mahitabo, katok karon si cat.codes, assignan niya og numeric equivalent ang carrier based on its alphabetical order. Okay, so ang output niya mauna ni. So you might ask, sir, nganong 1, 8, 7, 8, and 1? Unsa day iyang numbering? Okay. This actually starts counting at 0. So mapansin ninyo, lahi ang ato ang numbering dinhi because we started counting at 1. So ang ato ang AS dinhi is 2, whereas dito sa PCAS ang AS nato is 1. So ang nahitabo, this is 0, this is 1, this is 2, 3, 4, 5, and so on. So we start with 0, we end with 10. Okay, nakuha. So basin lang matingala mo, sir, nganong lahi man og numbering. Okay? Lahi obviously kay sa 0 man siya nagsugod og ihap. Nya. Kung tanawon na to ang pattern, pareho lang. Diba ganina, it's 2, 9, 8, 9, 2. Karon nahimo siyang 1, 8, 7, 8, 1. So in a way, makaingon gihapon ta nga, it's the same original values that we actually took into account and then saka nato siya gipulihan og numeric equivalent. Pero this time, ang ato ang ordering nagsugod sa 0. Okay? So mao na siya. Yeah. We can also get the same result if we are to make use of the label encoder method. No? So, label encoder is again a built-in method under the pre-processing package of sklearn library. So, create og panibagong copy, create og object ni label encoder, and then call it to do the fit and transform. So, unsay nahitabo dire? Flights underscore frame, yeah, square bracket carrier, the original values, okay, kato si AA, AS, and so on, mo na atong ginatawag dire. So, based atong ilahang pagkasunod-sunod, assignan sila og numeric equivalent. And then, katong numeric equivalent, gibutang nato dili directly kay carrier, just so we see that each values are associated to the same carrier. Nagdungag tag panibagong column, gipanganlan nato og carrier code. Dito nato gibutang tong mga numeric values nga na-generate ni label encoder nato. Okay, so makita nato, we still get 1, 8, 7, 8, and 1. So pwede ra, kani diri, instead of calling carrier underscore code, we can just simply call carrier, and that automatically replaces this carrier feature with the numeric values that we were able to generate using the label encoder object. Okay, so muna siya. The last technique is one-hot encoding. So again, sugod ta sa pag-create sa copy. And then, to do the one-hot encoding, ang atong gigamit is ang built-in method under the pandas library, si get dummies. So unsa ang iyang unsa bang ginabuhat sa one-hot encoding? Katong mga unique values for the column that needs to be encoded, i-identify to sila and then i-add to sila as new columns. Okay? And then for each column, check lang niya, asa ba probably na belong tong ako ang record. So, unsay pasabot na to, ana? Di ba kung tanawon na to dire, first record, ang iyang carrier is AS. Ang second record, ang iyang carrier is US, and so on and so forth. So, natay 11 kabuok, is it 11 unique values for our 1, 2, 3, 4, 5. Okay, na 11. Okay, 11 ka unique values for our carrier. So, unsay mahitabo? Naay madungag na 11 kabag-ong column. Again, one column for each unique value dito kay carrier na feature niya. Kung asa na belong ni siya na record, butangan niya og 1. All the other columns butangan niya 0. So, sama ani. The second record or the second sample that we have in our dataset, kabalota nga, this belongs to US or ang iyahang carrier US. Therefore, sa carrier underscore US nga column, dito lang pod nag-reflect ang 1. All the other columns, 0 ang nakabutang. Okay? So, ingana pod actually ang nahitabo sa tanang record sa ato ang dataset. We just opted to demonstrate the first 5 records. Okay? So, muna siya. Now, aside kay get dummies, which is again na belong kay pandas nga library, na ako'y laing method na pwede nato gamiton, yet we are also able to come up with the same result. No? So, what we are referring to is the label binarizer of the pre-processing package. Asa makita si pre-processing na package again kay sklearn. Okay, so Nag-create og copy, nag-create ta og object sa ato ang label binarizer na method, and then we do fit and then transform. Tapos, we created something like this one. A new data frame. Nga naman, kay ang kanimong results na to, this is just basically an array. No? So, we had to create a data frame and then ipasa na to sa data frame nga constructor ang katong ato ang na-create nga array. So, kung tan-awon ninyo, this is almost exactly the same except that wala na tong prefix na carrier. Pero, na-identify gihapon niya ang unique na mga values sa carrier na column or sa carrier na feature. Pero ang iyang i-return, kanilang pod specific. A data frame containing new columns based on the unique values that can be found on the feature being examined. In this case, si carrier. So, para mausa na to sila, mugamit taog concat nga method. So, concat is a method under pandas. Kung ma-remember nyo ganina ni try ta gamit og concatenate, that's a different method. Katong nga method si concatenate, while they actually have the same purpose, sumpayon nila ang two separate objects. Si concatenate is for numpy array, si concat is for pandas. No? So, katong ato ang na-create nga data frame dire ug ang kato ang ato ang data frame originally gisumpay lang nato through concat. So makita nato napagihapon to si carrier nga column pero naanay mga nadungag na columns which are actually based ra pod sa original or unique values that can be found in the carrier na feature. So because we already have these values, the result of our one-hot encoding, pwede na nato ni actually i-drop ang ato ang carrier na column and just make use of the added columns, okay, for our analysis. So that pretty much sums our feature encoding examples. Again, these are just few of the many examples that can be found if you read from other resources or if you search over the internet, no? Kani atong gipang pili tungod kay kanitong mga dali lang i-implement and then it is applicable for categorical features. No, so napay laing mga pwede nato gamiton. Okay, so questions? Nasundan ba to tanan? Okay, thank you, Ms. Lalis, for responding. How about the rest? Yes, Mr. Bandong, ako ang i-upload, i-provide na ko sa inyo ha ang kaning notebook na ato ang gigamit for the demonstration. Okay, para at least kamo personally, you can try it. Okay, for sure, murag lisod man gud sundan to tanan if we are to manually type all the syntaxes that were used. So, unya, as I hand you the notebooks, pwede ninyo to sulayan. Kana kung gusto ninyo nga i-revisit sila. Okay, you're welcome. Any other questions? So, mag-expect na mo, no? Our next meeting, di ba, is Thursday. Kaya lang, wala naman tayo klase, anak. Examination naman na siya. I don't know if I can follow the exam schedule. So, Kung ugaling man na ay adjustments, I will let you know. But before the exam schedule, na ko i-dedicate nga day wherein I'll ask you to do some activities and take some quizzes, just like what we did in the prelim. No? So katong mga quizzes, mamahimo na pud to silang paagi aron ma-prepare mo sa exam. Okay? So kay wala pa may exam, kung naamoy mga points of clarifications with the things that we have done so far, please feel free to reach me out. Okay? Kabalo naman mo unsay mga pamaagi aron ma-raise ninyo inyong mga concerns. Naa pa ba yung mga laing pangutana? Okay, I presume wala na. Mr. Golanes, pwede ta ka ma-request to lead our closing prayer?
Hello?
Madungog.
Okay, so the cause forecast ng dapat color na Father, Son, and Holy Spirit. Lord, thank you for this wonderful afternoon that we have our lesson. Please guide us we have our upcoming exam this week. In your name we pray. Amen. Father, Son, and
Amen.
Holy Spirit.
Father of the Son of the Holy Spirit. Amen. No? With all the echoing. Okay, so before di ko makalimot, I think Miss Pisau, being the first to join the meeting, I don't know kung either ako or ikaw ang mamahimong owner aning recording. So in the event lang, Miss Pisau, nga maadto sa imuha ang ownership, paki-check palihog ha para ma-share na to again sa tanan. If ikaw, galing ang owner, i-post na lang dito palihog sa to ang Google Classroom. Okay, daghan kaayong salamat. Sige, without further delay, okay, I will see you again, no, in the exam. Exam naman ato ang next na meeting na gyud. Okay, have a wonderful evening ahead and you are all dismissed.